In so many videos, almost 8 videos, I have covered the whole solution chapter of class 12. We have almost completed all the topics which are related to solution of class 12. So good morning to all. This is the last video of this chapter, and today we are going to discuss the numericals of colligative property and Vent-Hoff factor. Okay, so let's start the video. So first numerical is calculate the freezing point of a solution containing 0.5 gram of KCl. Molar mass of KCl is given, dissolved in 100 gram of water, assuming KCl to be 92% ionized. So since given, what are the given are there in the question? The first thing is the WB, that the mass of the KCl, that is 0.5 gram. Next, what is given here? WA, that is mass of water, 100 gram. Next thing it is given, the molar mass of KCl, MB, equals to 74.5 gram per mole, and the Kf value is given, Kf equals to 1.86 Kelvin kg mole inverse. Okay, so these things are given, and another thing is given that the ionization is 92% ionized. 92% ionized. It means what? That KCl is dissociating. 92% ionized means KCl is dissociating into K plus and Cl minus. The KCl is dissociating into K plus and Cl minus. So let's start from the ionization part. So 92% ionized. So it means alpha equals to 92 by 100. 92 by 100, which is equals to 0.92. So the degree of dissociation is equals to 0.92. So when there is dissociation, clear? When there is dissociation, alpha equals to what? Alpha equals to I minus 1 by M minus 1. Whenever there is dissociation, alpha is equals to degree of dissociation equals to I minus 1 M minus 1. Alpha value is 0.92. Alpha value is 0.92, and I value we have to find out, I minus 1. What is M? KCl giving 2 ions, K plus and Cl minus. So M value will be 2 minus 1. So what answer we will get? 0.92 equals to I minus 1, because 2 minus 1, it is denominator 1. So it means I equals to what? 0.92 plus 1, that is equals to 1.92. So the I value will comes 1.92. I value will comes 1.92. So I am rubbing this one because now we are going to find out the freezing point of the solution. So according to corrected formula of colligative property by Vent-Hoff, according to Vent-Hoff, the corrected formula of colligative property is delta TF is equals to I KF into molality. So we can write it as I into KF into molality can be written as mass of the solute into 1000 divided by molar mass of the solute into mass of the solvent. So now put the formula from the given. What is the value of the each individual component? Okay, we will put the values. So here the I value is 1.92. What is Kf value? Kf value is 1.86. What is WB value? 0.5 into 1000 by MB. MB is 74.5 and WA is 100. So when we will solve this equation, means when we will multiply and then we will divide, what we will get? We will get 0.24. We will get the delta TF. The change in freezing point is 0.24. Clear? But what we have to find out? We have to find out the TF. TF naught is the pure freezing point. TF naught is the pure freezing point and TF is the freezing point of the solution. So delta TF is equals to what? TF naught minus TF. TF naught minus TF. So what is the freezing point of water? Actual freezing point of water, it is 273.15 and minus TF, we have to find out the TF. And what is delta TF? We have got 0.24. It is 0.24. So TF is equals to 273.15 minus 0.24 minus 0.24. So what answer we will get? We will get 272.91 Kelvin. 272.91 what? 91 Kelvin. Clear? So this is the answer of the 272.91 Kelvin. This is the answer of the TF. So this is the freezing point of the solution. Clear? Next question. 3.9 gram of benzoic acid dissolved in 49 gram of benzene shows a depression in freezing point of 1.62 Kelvin. Calculate the Vent-Off factor and predict the nature of the solute. Means it associate or dissociate, that we have to predict. So first of all, what are the given are there in the question? The given are first of all we will see what are the things given. 49 gram of benzene is given and 3.9 gram of benzoic acid, means WB equals to 3.9 gram. Clear? Dissolved in 49 gram of benzene means WA equals to 49 gram. Clear? Shows a depression in freezing point of 1.62 Kelvin. It means delta TF is equals to 1.62. Okay. Calculate the Vent-Off factor and predict the nature of the solute. So let's start from the formula. So according to the corrected formula of colligative property, delta TF can be written as I into KF into WB into 1000 by WA into what? WA into MB. Okay. So but here we have to find out the molar mass. Molar mass, we have to find out the molar mass, and that is the abnormal molar mass. Okay, means whatever we are getting from this formula, that is the abnormal molar mass. Normal molar mass is given here, 122 gram per mole. So we have to find out the abnormal molar mass. So MB we will come to this side and TF we will take it this side. Then what is the I value? What is the I value here? Vent-Off factor, or simply we will later on we will see we will first of all do the formula by the colligative property. We will not put I. Later on we will find out the I. So because we have to find out the MB. Okay, I is also unknown, but later on we can find out, because I equals to normal molar mass by abnormal. So later on we will find out the I. So first of all we will find MB. So what is the KF value? KF value is given 4.9. So we will put the value 4.9 into WB is 3.9 gram. So WB is 3.9 gram into 1000. Clear? Divided by WA 49 gram and MB we have find out, and delta TF is 1.62. So we will put the value of delta TF 1.62. So if we will solve this equation, what will be the answer? The answer will be 240.74 gram per mole. Clear? So this is the abnormal molar mass. Abnormal molar mass. Clear? This is the abnormal molar mass. Now, according to the formula of the Van 't Hoff factor, I can be written as normal molar mass by normal molar mass by abnormal molar mass. Abnormal molar mass. Okay, because here in the question it is given calculate the Van 't Hoff factor. Calculate the Van 't Hoff factor. So now we will find out the Van 't Hoff factor, that is I. So what is the abnormal molar mass and the normal molar mass? Normal molar mass is 122 gram per mole. And what is the abnormal molar mass? We have find out 240.74. Okay, so when we will solve this, we will get 0.506. That is the value of I. I equals to 0.506. 0.506. That's why here what we can see, that I value is less than 1. I value is less than 1. 0.506 means it is less than 1. It means the solute undergoes association. When I value is less than 1, then it is association. When it is greater than 1, it is dissociation. When it is equals to 1, then at that time there is no association and no dissociation. Clear to all? So this is the second numerical in which we have find out the I value, and from the I value we have told whether it will associate or dissociate. As the I value is less than 1, that's why there is association. So third numerical, 19.5 gram of CH2FCOOH fluoroacetic acid is dissolved in 500 gram of water. The depression in freezing point observed is 1 degree centigrade. Calculate the Van 't Hoff factor and Ka of the fluoroacetic acid. Kf value is given. So first of all we will start what are the given are there. Given is the WB. Given WB is equals to 19.5 gram. 19.5 gram. Clear? Then WA is 500 gram. WA is equals to 500 gram. Clear? Next thing is that the depression in freezing point is 1 degree Celsius, means delta TF is equals to 1 degree Celsius. 1 degree Celsius. Clear? So first of all we will find out the molality and then we will find out its I value. So molality is equals to, molality means small m equals to what? WB into 1000, WB into 1000 by what? MB into WA. MB into WA. Clear? So what will be the value of WB? WB value is 19.5. 19.5 into 1000. WA is here 500 gram. Okay, and if we will calculate from this formula, the molar mass of fluoroacetic acid mass will be considered as 78 gram per mole. So it is 78 gram per mole. Clear? We will consider it as a 78 gram per mole. So if we will solve this equation, what will be the molality? The molality will comes 0.5 kg, 0.5 mole per kg. So this is the value of the molality. 0.5 mole per kg will be the molality. Clear? Next what we know, that delta TF is equals to I into Kf into molality. into molality. Clear? Delta TF equals to I into KF into molality. Clear? So we can find out, because we have KF 1.86, we have molality, and we have delta TF that is equals to 1 degree centigrade. So I equals to what? I equals to delta TF by KF into molality. So now we will put the value. Delta TF is 1, KF is 1.86 into molality is coming 0.5. It is into 0.5. So what will be the I value? I value will be equals to, if you will calculate this one, what will be the I value? I value will be equals to 1.07. 1.0753. 1.0753. Clear? So this is the I value when we will calculate this one. Clear? So I value has came. Next, what we have to find out? We have to find out, calculate the Van't Hoff factor, and then we have to find out the Ka. So before going to Ka, since here dissociation is there, what is the dissociation? CS2FCOOH will dissociate into what? CH2FCOO minus plus H plus. This is the dissociation. Okay, this is the dissociation. So it dissociate into two ions. It dissociate into two ions. That's why the alpha value will be equals to I minus 1 by what? I minus 1 by m minus 1. Since dissociation is there, that's why alpha equals to I minus 1 by m minus 1. So if we will put the value of I value is 1.0753 minus 1, m minus 1, 2 minus 1 is 1, denominator is 1, so alpha value will be equals to 1.0753. 1.0753. So here the alpha value will be equals to 0.0753. 0.0753, because 1.0753 minus 1, so it will come 0.0753. So alpha value is equals to 0.0753. Clear? So you take the screenshot of this one, then I will rub it and we will proceed for the Ka value. That is the dissociation constant. So this is the degree of dissociation. Now see, what is the initial concentration? What is the initial concentration of this fluoroacetic acid? In the molality we have find out it is 0.5. In the molality we have find out, you can check it. Previously you can check it, we have taken 0.5, that is 19.5 divided by 78. Molar mass of the fluoroacetic acid is 78. So number of moles is 0.5. When we are calculating the molality, at that time we are getting this one, that is 0.5. Yes, concentration we are getting 0.5. Clear? So here we are getting the concentration as 0.5. Initially the concentration of the fluoroacetic acid is 0.5, and this one at that time initially it is 0.0. When the dissociation has not started, at that time initially the concentration of fluoroacetic acid is 0.5. So it is 0 and this is 0. Clear? Next, so what is the alpha? Degree of alpha? Alpha amount is formed. Alpha amount of what? 0.5 alpha of the fluoroacetate is formed, and 0.5 alpha of what? Of hydrogen ion formed, because from this alpha amount has dissociated, so it is multiplied with alpha. So at that time how much is left? 1 minus 0.5 alpha. This much amount of fluoroacetate has left. Clear? So what is Ka? Ka equals to what? 0.5 alpha into 0.5 alpha. That is the concentration of the product by concentration of the what? Concentration of the reactant, that is 0.5 alpha. So alpha will be cancelled out. Alpha will be cancelled out. So 0.5 and 0.5. It is 0.25 by 0.5. And what is alpha? Alpha value we have got into 0.0753. So when you will solve this one, what will be the value? The value will be 3.07 into 10 to the power minus 1 into 10 to the power minus 3. This will be the dissociation constant. So in this case the answer will be this one, that is 3.07 into 10 to the power minus 3. This is the dissociation constant. This is the degree of dissociation. And what is I? I is here. I we have find out. What is I value? 1.0753. So this is the solution of this numerical. So next question, and this is the last question of this chapter. We will discuss in this video. This is the last numerical we will discuss. Okay, later on you can see the numericals are like this only. Okay, so you can practice some more numericals by your own. So this numerical we will start. The degree of dissociation of calcium nitrate in dilute aqueous solution containing 7 gram of the salt per 100 gram of water at 100 degree centigrade is 70%. Means the dissociation is 70%. The vapor pressure of water is given 760 mm and calculate the vapor pressure of the solution. So let's start from the numerical. What is the solution of this numerical? Here it is given that the dissociation takes place. So here the molecule is calcium nitrate. Calcium nitrate means CaNO3 whole 2. Here the compound is calcium nitrate. The compound is calcium nitrate, CaNO3 whole 2. So when it dissociate, it will dissociate into calcium 2 plus 2 molecules of nitrate. So what will be the M value? M value is equals to 3. Here the M value is equals to 3, and this question is related to dissociation. So M equals to 3. So here alpha is equals to 70%. So alpha, what we can write? Alpha is equals to 70 by 100. That is equals to 0.7. Alpha equals to 0.7. So alpha, we know that alpha is equals to I minus 1 by M minus 1. Okay. So here alpha value 0.7. Okay. I value we have to find out, minus 1. M value we will get 3. So 3 minus 1. So what value we will get? We will get 3 minus 1. 3 minus 1 is what? 2. So 0.7 into 2 equals to I minus 1. So what is 0.7 into 2? It is 1.4 equals to I minus 1. It means I is equals to 1.4 plus 1. So 1.4 plus 1, that is equals to 2.4. So here the I value is equals to 2.4. Clear? So here we have find out the I value equals to 2.4. Next we will go to the corrected formula of the colligative property of the relative lowering in vapor pressure. So relative lowering in vapor pressure, that is P naught minus P by P naught equals to I, and then the mole fraction of the solute. So mole fraction of the solute means what? Mole fraction of the solute, what we can write? Because here given the degree of dissociation of calcium nitrate in dilute aqueous solution, 7 gram of the salt per 100 gram of water. So NB, NB 7 gram. 7 gram is there. So here we will put the, so first of all we will write the formula, that is WB by what? MB. WB by MB by WB by MB plus WA by MA. WA by MA. So we have to put the formula, and also we have to find out the molar mass of calcium nitrate. Calcium nitrate you can find out, calcium is 40, then nitrogen is 14, oxygen is 16 into 3, that is 48 into 2 into 2. So what answer we will get for the molar mass of the calcium nitrate? Calcium nitrate. So 14 plus 48, how much value we will get? 40 plus 2 into 8, 4, 12, carry 1, 4, 5 and 6, 62. Okay, into 2, 4, 12, 124 plus 40, what value we will get? It is 164. It is 164, that is the molar mass of calcium nitrate. Clear? So if we will put the values, what is P naught? 760 minus P, and by P naught is 760. 760. Then I value what we got? I value we have calculated. What is the I value? In the starting, what we have calculated? I minus 1, I equals to 2.4 we have calculated. So 2.4. WB 7 gram. 7 by 164 divided by 7 by 164 plus water. How much water is there? 100 gram of water, means 100 by 18. 100 by 18. You solve this one, what answer you will get? So finally, where this P we will get, P equals to we will get the value 745.99 mm. So if we will solve this, the P value will come 745.99 mm. So in this way we can solve the numericals of colligative property and Vent factor, and in this way we have completed the second chapter of class 12, that is solution. So thank you and have a nice day.